Hi guys, we're looking at 2024 AMC 8 problem 7 with this diagram over here, and it's a sort of logic puzzle problem. So we start with a 3 by 7 rectangle, and it's covered by, without overlap, by three shapes of tiles, a 2 by 2, a 1 by 4, and a 1 by 1 as shown below. What is the minimum possible number of 1 by 1 tiles used? So we can try this. You can try this on your own, um, as many times as you like. So let's say I start with a 1 by 4 here, a 2 by 2 here, another 2 by 2 here, and then we're left with this sort of awkward 3 by 3. And let's say we put another 2 by 2 here. We have 5 tiles left over, which doesn't really seem like the most optimal way of filling this up. But you can try this as many times as you like, but it really is kind of a tricky problem. And one of the methods that I think is very helpful to use is through counting the area and seeing how exactly we can fill up this area. So this is a 3 by 7 rectangle, which means that its area should be 21. Now what we're trying to fill it with is this is a 2 by 2, which is area of 4, and this is a 1 by 4, which is area of 4, meaning that each of these covers 4 squares, right? And then we have, of course, a 1 by 1, which is area 1. So if we want to fill 21 with just these two tiles, it's not possible because they each have an area of 4. Instead, we can fill up to maybe 20 of these squares, since that is a multiple of 4, or maybe up to 16, which is what we had before with 5 left over, right? So we know that our only possible coverage is a multiple of 4, which means our only possible leftovers is either 1 in the 20 case or 5 in the 16 case. So we can eliminate all of these answers already. Now we kind of just have to play around with it and see if we can actually get 1 left over in the 20 case, which I feel like if you mess around with it a bit, you'll realize that it really isn't possible. Um, it's not very easy to prove here, but I think, let's say if you have just like a 1 in any row or any column, right? This doesn't really matter entirely. We know that this here, 6, can be filled by a length of 2, let's say here, and a length of 4. The only problem is the rest of these really can't, right? When we have 7 to deal with, we can't fill that up with something with a length of 2 and something with a length of 4. It's just not possible, right? So we need extra ones, and so there's no way we can just have one of these 1 by 1s. So if you want to play around a little bit, and if you don't believe me, you can keep trying, but our answer here is 5, which honestly doesn't seem like the best. It doesn't seem like we're optimizing the space enough, but it is the actual answer. All right, thanks guys.